You can ask, can I get all the answers to the test? And I'll say, man, I really hope so, because then you get 100. But I won't give it to you. But hey, it's a good question to ask. You never know. Yes?
Can you go over to C on the practice test?
Yeah, let's see. All right, so help me out, guys. Do you get stuck on a part, or are you not sure where to start?
Just don't know what to do.
Okay. Order operations. I haven't explicitly said this. What's the very first thing on order operations? Parentheses. Absolute values are like parentheses. They just have one extra thing. They have to make the stuff inside of them not negative, correct? So, with that in mind, what's the very first thing I should do? No, definitely, hell no. If I say, what's the absolute value of a number, and I'm not going to tell you what the number is, can you tell me what the absolute value is? No. So I have no idea at the moment what's inside this first set of absolute values. I have no idea what the number is. Can I just make the minus become a plus? Shit, no. What's the absolute value of 4 minus 1? 3, not 4 plus 1, 5, correct? I really want you guys with me. The absolute value takes the number that is inside of it and makes it not negative, correct? If I don't know what the number is inside of it yet, I can't do that yet. Good. So, order operations. Parentheses. Absolute values also go with parentheses. I do inside the parentheses, I can do either one of these. So this one, what do I do first in here? Exponent. Kick ass. Are you guys kind of with me? So absolute values look like parentheses that somebody just hammered straight. So they fall at the same place in order operations. I do inside of them first. And when I look inside of that one, 2 cubed is what I do first, correct? Okay, so go a little further with it. I'll catch up to you in a minute. If you haven't tried this one yet, do that first. Dying, poor little dude. Poor little dude. I barely do. Okay, let's see. Here we go. What is 2 cubed?
8.
Crazy sauce. What can I do in this other set here? What would I do first in this set here?
Multiply 3 times 4.
You could, but that just makes it worse. Order operation says, what do I do first? Inside the parentheses, right? So I do inside either of these, but inside this, isn't there another? So then I do this first. Do you guys see what I'm saying? Don't you always go to the innermost parentheses when you start to simplify? That's what you do. What is 4 minus 8?
Negative.
Holy shit. Okay. So what was it that made me do what I did? Absolute values are like parentheses. They're in the same place in the order of operations. So I have 2 little sections I could do first, right? As I destroy all my calculators. This section, in which case I do the exponent first, and then this section, in which case I do its parenthesis first. Now I reevaluate. What can I do in that first set? Yeah, what's 7 minus 8? Holy shit. And what can I do over here? Yeah, what's this? 3 times negative 4 is? Negative 12. 12 divided by negative 12 is? Okay, let me stop for a minute. Is everybody with me? So, am I going to ever give you this problem? Am I going to give you a problem like this one? Yes. Shit, yes. So whenever we're doing a problem together, the most important thing is, why did I do what I did? What made me do what I did? Because you're going to have to apply the idea. You're not going to see this problem. You're not going to memorize this problem. That would make no sense. Why did I do what I did? Okay. You're all like, yeah. So now what can I do? What's the absolute value of negative 1? So that this becomes negative 1. And what's the absolute value of negative 1? Okay. So again, negative 1 plus 1? 0. Okay. Voila. Okay. Yes.
Can you go over even, odd, and neither functions?
Yes. Is everybody cool with that one? Okay. So, if I give you a function, okay. Yeah. Let's pretend like I don't notice this will reduce. Just watch. An even function is like a parabola. Even is like the power is even, yes? So an even function, when I plug the negative number in, I'll get the same output. So the idea of an even function is if I plug a negative input in, my output is the same. X squared is even because 2 squared is 4 and negative 2 squared is 4. The output is the same even if I change the sign of the input. Are you guys with me? That's an even function. So how do you remember what even function is? X to the even power looks like this. Odd function is like x cubed. What's 2 cubed? Holy shit. And what's negative 2 cubed? Negative 8. So for an odd function, when I plug a negative number, an opposite sign input in, I get the opposite sign output. So then that leads to the test. Do you notice either one of the things I just said was about plugging a negative in? So whenever I ask you, is this even or odd, you just immediately plug a negative in. You guys with me? Because if I get the same thing out, it's even. If I get the negative of the original out, it's odd. And if I get neither one of those, it's neither. Okay.
I think the book explained it in a different way.
Okay.
They put a negative on the outside of the function.
No. That's what you compare it to.
Oh, that's
Yeah.
Okay.
So can anyone help me out? What happens here? The top I'll do. What's negative x cubed?
Negative X.
Yeah, it's kind of funny. Negative x cubed, yes? What's negative x to the 5th? Can anyone see what you can do with that? Is there something common to the top and the bottom? Yeah, but let's not do that far. I kind of made one that's a little bit weird. Can I cancel all the negatives out?
Yeah.
How does this compare to the original function?
It's the same.
It's the same. So is it even or odd symmetry? I plug negative in, and I get the same output as I did the original. Even. If I get the exact same thing out, it's even. Because 2 squared and negative 2 squared are the exact same thing. If I get the negative output, it's odd. Because 2 cubed is the opposite of negative 2 cubed. 8 and negative 8. You guys get that? That's all there is to it. This is how you remember even, odd. Even power, odd power. So what's the test for either symmetry? Plug a negative x in. You do the same thing. You just analyze what you get at the end. So what if I had, what if you had what, Jeff? I don't know, man. You can do it. X to the 4th minus x to the 8th plus 3. What's f of negative x? What's negative x to the 4th power? X to the 4th power, because 4 negatives cancel, right? Every 2 negatives kill each other. So what's negative x to the 8th? And what's between those two things? This is where people make mistakes. A minus sign, yes. So that negative canceled, that negative's still there, yes? And of course, 3 didn't give a shit. 3 don't give no. So how does that compare to the original? Same. So again, this is even. Okay. Okay. Is that better? Whoever asked the question. I mean, that is it. That is all there is to even and odd. Just plug a negative x in. Do you get the same thing out? Even. Do you get the negative of the original out? Odd. Do you get neither of those? Neither. Yes. 7. Which one? 7D? B. This one? Alright, help me out with that one, guys. Is that a cubes? I see a third power. Is that a cubes? No, like, I don't know, man. You're supposed to know. Why is it not a cubes? Yeah, I can't do 6, I can't do 48, I can't do y. I can't break everything up into thirds. I can only do w to the third power, so that's definitely not a cubes. But what saves your ass? What's the first thing you should always try? 3 letters, no. Oh, I see. Undistributed. GCF. Is there anything common to both terms? 6y, 11. So if I take a 6y out, what am I left with? W cubed minus 8. Now is this something? Yeah, what's this? Yeah, it's cubes. Okay, so I can cut both of them up into 3 parts, so it's cubes. Let me stop for a minute. If I ask you to factor something, the very first thing you do is GCF. You try. Maybe a number comes out and makes it easier. Maybe a number comes out and makes it possible. Maybe a number comes out, or something comes out, and that's all you can do. So always try GCF first. How the hell does this work? You started telling me over there. What do I put down here? Thank you. That always makes me so happy. So little guy, big guy. W cubed is WWW. 8 is 2 times 2 times 2. So when the little guy goes, here, you guys take a minute. Put those together. I'll catch up to you. Didn't quite get done with all your stuff. Bryce. There you go. Tran. Search party. Okay, catch up to you. What goes in the little tiny dude? W minus. Good. 2. So 1 W, 1 2. So over here, of course, goes the other 2 W's, the other 2 2's. What's this sign always? Plus. And what's this middle sign in this case? Good. Plus. The opposite of the little dude, right? What goes in the middle? 2 W. Bam! 1 of each, 2 of each, product in the middle. You can make it a song if you really want to. Now, a lot of people hate that, but to me, it's just the weirdest part is this guy. Do you guys agree?
Yeah.
That's the weirdest part. But you just got to, whatever's in the little guy, multiply them together. 1 W, so the other 2 W's. 1 2, so the other 2 2's. I mean, that makes sense because it's got to make 3 total. The middle guy's weird, but his job is to clean up the shit I don't want. And we looked at that before, how it does that. Is that all right? I'm sorry. That must be okay. Yeah.
Can you go over 4E?
Oh, yeah, okay. So how do you guys, I've given you a couple different ways to think about average rate of change. To me, I wouldn't do it the way the book's got it. I would what does average rate of change mean? Slope. So I would just get the points and then find y2 minus y1 y, which is really the same thing in the book, but when the book puts f of x2 minus f of x, It just makes it look worse than what it is. So, what do these mean? X values. So what do I need to figure out? I need to figure out the Y values. So what's one Y value I got to figure out? F of 1 and F of 15. So what's F of 1? Don't forget the plus 2. When you plug a 1 in, what do you get? 2 minus 3 is? What's the cube root of negative 1? Negative 1 plus 2? 1. What's F of 15? Twice 15 is? Minus 3 is? Cube root of 27 is? Plus 2 is? 5. Okay. So to me, it's just a lot easier. Let me get the y's and then just do slope like I did in freaking algebra. So it's the difference in my y's, 5 minus 1, divided by what? 15 minus 1. There you go. Yeah, the difference in my y's divided by the difference in my x's. So when I ask you average rate of change of this function, you think yourself slope. Let me get the 2 points, get the slope. We are doing the formula that I put above there. We're doing it, just we're not doing it making it look like that, because that just looks a little more confusing. Yeah.
2G.
Say again?
2G.
2G. Is that okay with everybody? You get, what do you get? And then you can reduce that, right? So 2G? Oh, this one? All right. Anybody have a clue what to do with that? Yeah. Go ahead, it's all right. Now's the time to make mistakes, because I ain't great yet.
Multiply by 3 minus 2i.
Not quite. He's close, yeah. 3 plus 2i. And the whole reason is I want there to be no. Do you all agree that complex numbers are weird? If you don't, you're an interesting person. I want to talk to you some more, but they are weird. So it's even worse if they're being divided, yes? So what I want to have happen is I want to make there be no i's on the bottom. If I multiply by 3 minus 2i, I'm going to get a middle term. It's going to have i's in it. Can you guys see that? So I got to multiply by the difference of squares pair, the 3 plus 2i, because then the middle terms cancel. And what's I times I? Negative 1. Yes, I squared negative 1. Yes. So the whole reason we do the conjugate is so that I end up with no i's in the bottom. The only place there could be i's is in the middle term. So if I just make sure the middle term dies, there won't be no more i's. I'm a poet and didn't realize it. So I multiply what by what again?
3 plus 2i.
3 plus 2i. Why is the top kind of nice? Because all you got to do is distribute. And then the bottom you FOIL, but you can you built it so the middle terms cancel. So you can really just do 3 times 3 and negative 2i times 2i. You guys get that? You guys see that? So the bottom should end up with no i's. The biggest mistake people make on this kind of problem is they replace I with negative 1. Is I equal to negative 1? What's I equal to? Square root of negative 1. So we don't replace that because it's weird. We just put an I so we don't have to look at that weirdness. So what do you get on the top? 12i plus 8i squared, but I squared is, so that's going to become 12i minus 8, right? Yeah. Down here I'm going to get 9 minus 4i squared, and the middle terms cancel, so I don't have to worry about them. But what's I squared again? So the bottom is going to become 9 plus 4, yes? And the top is going to become 12i minus 8, because I squared is negative 1, yeah? Does somebody remember the general form of a complex number? Is 3 plus 2i a complex number? Yes, why? It's got an imaginary part, and it's got a real part. So a general complex number is a plus bi. So isn't negative 8/13 like a, and 12/13 like b? So my answer is a complex number. It's in the right form. Okay. I love you guys. When I divide two real numbers, I get a real answer. When I divide two complex numbers, I get a complex answer. Yeah.
Can you go over like a question on the same?
7. Oh, 7, which one? 7D?
Yeah.
So we did that one, right?
Can you do like another?
Yeah, let me do 2. First one I'll do is a little more straightforward. And then I'll do one that's a little bit freakier. So what if I had this? Holy shit. What you got, Jeff? I don't know, Jeff. Yeah. All right, let me ask you a tricky kind of question. How many terms are there in that expression?
4.
Nope. Nope. Keep going.
6.
4, 3. 3. No, that song's gonna be stuck in my head. 2. There are 2 terms up there. Am I insane? I could, at any moment, I could go insane. It's really trippy. Try not to think about that. This minus sign separates this term from that term. These aren't terms because 3x minus 2 is a number and it's a part of this number minus this number. Do you see that? What do those 2 terms have in common? The numbers. What do they have in common number-wise? Just look at the numbers. What do they have in common? What number can come out of both 4 and 22? 2. Just look at the x's. How many x's do they have in common? 4. Just look at the 3x minus 2's. How many 3x minus 2's do they have in common? 4. X's. the shortcut for variable expression stuff? Take the smaller power out. Do you see how this dude has got 5 x's? So he can give 5 x's, but he's only got 4. That's not fair if I try to take 5 x's out, this guy's going to freak. So the shortcut is take the smaller power that you see. Take that out. Because that's what they both can give. Okay, maybe. It's like the semi-fair tax man. It won't take more than you got. You guys all right? You guys are looking at me like, but then you don't ask questions. You look at me like this. And then you don't say anything. I'll be okay. So definitely the number's easy. 2 comes out of those. What's the smaller power in the x's? 4. What's the smaller power in the 3x minus 2's? 4. So now you look at each piece. I had 4 divided by 2. Bam. I had 5 x's. I took 4. So 1 left. Good. And then I had 4 of these and I took them. All minus 22 divided by 2. Had 4 x's. Took them all. Had 5 3x minus 2's. Took 4 of them. So now I have 1 left. And what's the last thing you can do? Can't you do something here? Yeah. So you get 2x minus 33x plus 22, and then you just combine those and you're done. So that's one level of this problem. Is just noticing it's just a GCF problem. Watch this. Okay. Does this look better? What comes out of this? 2. X to the 4th. E to the 4th. And what are you left with? 2,
X,
x,
11,
11,
B.
and 1b, yes. If I made b 3x minus 2, I get the same damn thing, yes? If I make b 3x minus 2, kabam! Because what is 3x minus 2? Isn't it a number I don't know yet? And isn't b a number I don't know yet? So they're going to act the same. So if you thought that this was easier, I want you to realize they're the same level of hard. This one just has 2 more things to write. Yes? No? Okay. The other part of that problem is something I'm not going to focus too much on, to be honest. But just to show you one more example. Here, let's build up to this. What can I take out of these? Holy shit. Sorry. Is that all right? All right, so then how would this work? You can still take 2m out, but how many times do you do it? So what comes out? 2m to the 10th, and you're left with 2m minus 1, you're left with 10 of these. Look at this. Isn't this our first power? So isn't this one of these and one of these? So if I put a 10, it's 10 of these and 10 of these. Whoop-de-doo. So that was the other level of that problem. Maybe? Let me make a smaller example. Watch. You all agree I can take an x out of that? Okay, and watch. If this is a third power, isn't that x squared minus 2x, x squared minus 2x, x squared minus 2x? Yes? What can I take out of each of these? An x. So I get an x, x minus 2, x, x minus 2, x, x minus 2. That's a crappy way to write it, isn't it? What's a better way to write that? X times x times x is x cubed. X minus 2 times x minus 2 times x minus 2 is? All right then. See how we can just go from there straight to frickin' here? I take an x out 3 times, and I'm left with x minus 2 3 times. So if this is a 30th power, do you want to do it this way? Hell no! I'll just go straight to 30. 30. Yay, I'm done. Yay. Okay, maybe. Okay, good. I'm very happy. I just saw this. I just saw somebody go this. You know, that's my favorite. My favorite sound is, oh. My favorite facial expression is the same thing, just silent. All right, guys. Anything else you want to focus on from this weird ass thing? Now, real quick, we don't only have to talk about the practice test. We can talk about the quizzes. We can talk about the homework. Whatever question you've got, we can do. Is it pretty cool, this one? Oh, okay. It's like I can read your mind. This is one I'm like, if nobody asks, I'm going to ask. Does anyone remember, how do I do this? Absolute value. What's always going to be true about them in an equation inequality? They must have 2 possibilities, yes? So what are the 2 possibilities for this? Either this number is already bigger than 2. Do you all agree? If that number is already bigger than 2, then the absolute value is bigger than 2. Doesn't that make sense? Or 3 plus 5x less than negative 2. If I make it negative 3, isn't the absolute value negative 3 bigger than 2? So one case is exactly the same. The other case is change the sign, change the sign. And then you just solve each of those. Yes? Is that okay? So for a greater than, you're always going to have a picture that ends up looking like this, like 2 separate things, right? For a less than, you're always going to end up with what I call a sandwich. bread, jelly. Or whatever you like in a sandwich. By the way, a sandwich is a sandwich that is really yummy. That is a sandwich. Is that right? Is everybody okay with? Now you should be able to figure both of those out, yes? The one thing you have to be careful about with inequalities when you're solving is if you multiply or divide by a. If I have an inequality and I multiply or divide by a something, negative number, the sign's got to switch, right? Why? Because it does. And we looked at why. I gave you a concrete example why. Now remember, I do have the answer key for this, right? So don't, if you're like, finish it. I'm like, I already did. Yeah. So this is a beautiful example of what are you supposed to always try first? GCF. Is there a GCF? Yeah. Each term has one X at least, right? All right, so do that first. Take an X out. And again, it's not a real life advice. Don't take your X. So just every term loses an X. Doesn't this look a little more like it's in the right form now for a 3-term dude? What do I need now? 2 numbers that multiply to be negative 66. Add to be negative 5. And negative 66, what's the immediate obvious way to factor that? 6 and 11. And if I make the right one negative, I can make them add to be negative 5, right? You don't have to break the middle term out, because once you get the 2 numbers, you're done. When the first number is a 1, when the first coefficient is a 1, once I get the 2 numbers, I'm done. It'll be x blah times x blah, whatever the 2 numbers are. Yes? If you want to, you can. If you want to do more work, you always can. How are you? I'm like, I don't got the kind of time. What are the 2 numbers that work?
11, 6.
Yeah, so minus 11 plus 6. I'm done. I don't have to do any more. I just needed the 2 numbers. It's just that the first number is not a 1. Then I need some help. Then I got to break the middle term up. Yeah.
7C then?
Huh?
Can we look at 7C?
Sure. That's the last one, and I don't have any room. Let's see. 7C. Now, first number's not a 1. So what do you have to do first?
Multiply and see.
4 times negative 6, negative 24. We do this up here. What is it? 4b squared minus 5b minus 6. First step, negative 24. I need factors of negative 24 that add to be negative 5.
Negative 8.
Negative 8 and 3. And then you can split the middle term up using those coefficients, and then you can do what? Because I made 4 terms now, and now I can group. Is that the way I factor that? No. I don't do it that way. I'll show you the way I do it. You don't have to do it this way, but I want to show you at least once. So pretty cool with that. You just group. Each group is pretty simple, yep. Okay. The way I do this, please, dear God, you do not have to do it this way. I just want to show you this real quick. Here's what I do. First thing I do is I move the 4 over. Magically. I can do whatever I want to in the middle. This is my work. Then I just factor that. But wasn't the original thing 6? And isn't it supposed to be a 4 here? So watch what I do. Do you see how this is negative 8b? So if I make this like this, isn't this still negative 8b? And don't I get negative 8b plus 3b? Don't I get my 4b squared? Don't I get my minus 6 like I was supposed to? So please, dear God, you do not have to do it that way, because it gets really trippy the worse the numbers are. But just to show you there's other ways to do this stuff.
I was taught that way. Is that okay if we do that?
Oh, sure. Yeah, just make sure you show me all the steps.
Yeah, I was gonna say, this step.
Show me this step, show me this step, you're fine. I love it.
Okay.
When I was showed this method, it was called the Texas slide. I have no idea if that's the official name or if that was just the teacher that showed me. But I love it. Yeah. And
Would it be okay if I had the answer that I showed you that if you multiply to check it out?
so here's what I really want to see. I want to see this. If you want to do it this way, I want to see this progression. If I just see this and then you check it, I'm like, where did this come from? So a few of you guys give me this answer and then you multiply it out. I'm like, no. How did you get it in the first place? You can't check it until you get it. So you've got to show me something about how you got it. Because I want to make sure, maybe you're doing a method that only works sometimes. And if I never see what method you use, I can't tell you. Oh shit, be careful, it's not going to work. Because I need to see where it's coming from so I can help you in case you just got lucky getting the answer. Because again, I don't want you to take helpless and go, well, I did it my last teacher, it worked. Because I had no idea what you were doing. So of course I'm going to take points off if you don't show me work. Okay. If you just say, I don't know, I did it in my head. Okay, tell me what you did in your head. Tell me. Yes? Oh, yeah, and again, I'm sorry. You do not have to do it that way. This is really weird, yes? It's like I changed the problem, but I want you to notice, see how I took a factor of 4 and put it at the end? And just see here, I took a factor of 4 and put it back at the beginning? So at the end, I undo what I did at the beginning, so it becomes the same problem again. In the middle, I just made it a different, easier problem. I'm sorry.
The first, like, way how to solve it.
This way?
Yeah.
Yeah, that's the what's a good word for this? This is a more careful way to do it. This is the way to do it if you're not as comfortable playing around with numbers. Yeah. So obviously, I don't know if you know this about me, but I teach math. I'm really good at numbers, so I like something where I can just freaking play with the numbers in my head. Blah, 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 blah. Right? I understand not all of us are good. I can't draw worse shit. I can paint. I can't draw worse shit. Maybe somebody else can draw. We all have different skills. That's mine. So of course I'm going to do something that utilizes that skill. This way, everything kind of falls into place for you as you go. You don't have to kind of guess. You don't have to be clever with the numbers. Yeah. I just wanted to show you a different way, just in case somebody liked it. And it's kind of cool somebody taught you that way. It's nice. I don't see that too often. Okay.
Could you go over 2C?
That's the one I
Oh, you
won't.
already did it?
I'm not going to do it.
Oh.
No, I'm joking. We already did 2C, right?
Yeah. I came in late, never mind.
Oh, you're fine. Here it is, yeah. So let me do this. I'm going to give you the answer key. This is the first answer key you're getting from me, so don't do this. If you haven't tried the practice test, don't take this and do this. Yep. That's what I would have done. Right? Because then you're going to build false confidence. So if you didn't try the practice test at all, don't look at this thing at all. Because you're just going to build false confidence. It's easier to agree with me than to do the work. Okay. So make sure you guys don't fall into that trap. So let me know if I got any of these wrong. I'm averaging about a 97. Yeah, number 8 was weird. That's another one I should have asked if anybody had questions about. Without looking at my key, did anybody try number 8? I mean, the first part of number 8 is easy, yes? Why doesn't x squared have an inverse officially?
Horizontal line.
Doesn't pass a horizontal line test. So the whole idea of restricting the domain, if I could erase part of the graph, could you erase it to a point where what's left passes the horizontal line test? Erase the least you need to. So here's a parabola. Hi. That's beautiful. Look at that. That sucks. It's like a straight line. Can you erase? What's the least amount you can erase so that the rest passes the horizontal line test? Can you cover part of it and then the rest? Why does it not pass the horizontal line test? Because it hits this and then it hits that. So can't you just get rid of this? So I want my domain to start where then? If I want to chop all this shit off, where do I want my domain to start? 0. So if I do that, if I restrict my domain to be 0 to infinity, the picture becomes this. Does that have an inverse? In fact, you guys know, officially, squaring does not have an inverse. Because if I square a negative number, I don't know that that's what I did. I can't work backwards easy to exactly what it was. But we know that the opposite of squaring something is square rooting it. So if I restrict the domain and then I reflect this, don't I get the square root graph? Isn't this one the square root graph? There you go. Okay, so if my function does not pass the horizontal line test, I can chop the domain so the rest of it does. Now, in that case, what am I giving up? What can a square root not handle in it? And what can a square root never equal? A negative, correct? So I'm giving up my negatives, but I'm okay with that. Because now we have square roots and they're useful. Maybe? I don't know. So it's that simple. If you're like, if you were some deity and you have this graph and you're like, it's not, let me just erase part of it, just you don't exist anymore, then it will pass the horizontal line test. So when would this make sense physically? Well, downward parabola. Downward parabola could represent throwing a ball, yes? So if I'm here, if I'm this tall and I throw a ball, it does like this, yes? Math would say this is good, but I'm saying no, math, no. That's negative time. This shit's your problem. So we restrict the domain in everyday life because there's a point at which things start. Math says, I can keep going that graph, and we're like, stop it, math. That doesn't exist. Are you insane? I don't know if you guys are with me. Mathematically, negative answers are fine. Physically, you can't build a shed that's -8 by -10 feet. Don't do that shit, kids. I don't know what material you used. You're going to open some kind of portal to a horrible dimension. Maybe the event horizon kind of dimension.
Maybe in the upside down world, right?
Upside down, you have demogorgons coming. Not good. Okay, sorry. All right. Anything else? Does anyone see anything on my answer key looks sketchy? Anything else you guys want to talk about? How do you feel about this? Does this one have no solutions because it's negative? Hell no, because what do I do first? You're a tyrant in a country. What do you do with the radical element? You isolate it, so then you can get rid of it. Yes. So I got to add the x over first. And then I have no idea if x minus 1 is positive or negative, so I got to keep going. the upside down right there. Yeah.
So number 8, when we answer it, do we have to draw the graph too? Like that sketch?
Oh,
Or would
I didn't ask for a graph, but to me, that's the easiest way to sort of like show what's going on. But you could answer this with no graph. It would take a bit of writing to explain. But I didn't ask for a graph, so you could answer it without a graph. Yeah. It's just very often a graph is the easiest way to kind of show the idea of something. Yeah. So like on this one, what would I do first on part C up here? 5C.
you switch the 5 to 12?
So again,
You move the 5 to 12
by doing what?
by making it negative?
Minus 5. So subtract 5 from the, isolate the absolute value, and then continue, right? So we have this idea in equations. If I see my variable stuck somewhere, I get that part by itself first, and then I try to unstick it. With a square root, I get it by itself so I can square it. With an absolute value, I get it by itself so then I can write the two cases, right?
Negative, positive.
Mhm. Any of you guys go into the Math Science Center at all? Yeah. Just to remind you, you could go there, work on homework, and never talk to anybody. Just get your homework done, and knowing that there's somebody there that you can just grab and say, hey man, how do you do this? You can go there and sit down with a tutor, make an appointment, and have half an hour just sitting there with somebody. Go over this kind of problem with me. A lot, just get that down, right? So there's a few different ways to do that. I keep forgetting. Did I do that yet? Do you guys have? Did I talk about like YouTube channels for help? Like
You mentioned organic chemistry.
Organic Chemistry Tutor does some
Like
good
Khan
stuff.
Academy.
Khan Academy does some good stuff. There's a guy called Professor Leonard. He mostly does like calculus and stuff, but I don't know if he does pre-calculus stuff. Anyway. So if you're having trouble with stuff and you're not sure what to do, just reach out to me. If you have any like life stuff, does anyone have life stuff going on? All right, you don't have to get specific. Of course we got life stuff going on, right? Everybody does. You could talk to the success coaches. I've got stuff up on Canvas. Success coach to me is the best place to go because they hear what your situation is and then they connect you directly with the resources on campus that would respond to those situations. So you don't have to figure out for yourself, well, which place do I go to? You just say, here's what's going on. What can I do? And they'll connect you.
We used to have a social worker from here going around all the math classes.
Oh yeah, mind over
Minor for math, yeah.
math. We had, yeah. I think they stopped that for this semester for some reason. I'm not sure why. They had somebody come around and do the bowl, on the bowls.
Did they? No, I didn't get that.
Okay.
It just went over the different resources and counseling resources.
Yeah.
You can get free therapy here.
Yeah, you got free mental health here.
Limited, but
Sure, it's limited. Everything's limited.
Right.
Yeah, free health care, but I mean free nurses and stuff to go
Nurses,
see.
yeah.
But obviously they can't do like major surgery. So I mean, there's a limit. Yeah. But it's a great first place to go. food pantry, if you're food insecure, all that kind of stuff. It's crazy.
Gizmo's Kitchen.
Gizmo's Kitchen, yeah.
I have a question.
Yeah.
So we were talking about, 5C, right?
Bless you. Yeah.
So on the quiz, I got less points because I did two solutions. It was supposed to be just one, right? Because when it's equal to 0, when it's equal to 0, it's just one.
This one?
No.
Oh, this one, yeah. No. So there should be 2 answers. Yeah. I only see 1 answer. Yeah, that was the one. So yeah, either, the big problem is you started doing stuff before you set up your 2 cases. So the very first step there is 3x plus 6 equals 3 or 3x plus 6 equals negative 3. And you solve each of those, yeah.
So go to 5C.
One little thing. So looking at 5C. Let me get a fresh. So the first step on 5C is to subtract 5. Get the place where your variable is by itself. Oh, are you the bad one? Yeah, you're the bad one. Okay. What's the immediate next step? What must be true about the number in here? The absolute value of what is 7? What do I take the absolute value of to get 7?
7, -7.
Yeah.
Okay, so either the number inside is 7, or the number inside is -7. And then you solve those. That's how you get rid of the absolute value symbol is, and I really, okay, guys, can you tell me what that is? What is this? You're like, what do you want from me, man? It's algebra. You like that? No. It's a variable expression, but it's a number, correct? Isn't this a number? So that is some number, and this equation says the absolute value of it is 7. So what must that number be to make that true? That number must already be 7, or that number must be -7. That's the only way, 2 ways to make that true. And then you can solve each of those. Is that right? Okay. Yes.
Can you explain what
2F, this one's a little more straightforward than that one. What's my first step here? I mean, in order to multiply, I have to do repeated distribution, right? The FOIL thing, yeah? So I'm looking at I like it's a variable. We know it isn't, but I'm looking at it like it is. So as I do this, if I ever get an I squared somewhere, what is I squared? -1. I can replace it with -1. That's the only difference between, if I would have put 3 plus 2x times x minus 6, you all would jump all over that shit. You would FOIL the hell out of that, dude. The only difference here is, if I see I squared, I can do more with it. If I see x squared, I can't do shit with that, because I don't know what x is. Or he's like, damn straight. So I mean, what are you here? 3 times I? 3i. 3 times -6. Okay, now it's the 2i's turn. 2i times I. 2i times -6. So I can put my like terms together here, yes? And then this will be And then you can put that together with the negative 18, yeah? Okay. So the first step is pretend like I is just a variable. And the next step is if you see I squared, you know what that is. Okay. And then just get your like terms together.
Use 6.
6. Okay. How many transformations are there? 3. What are they in the order that you should do them in? Yeah, right 4. Vertical stretch, I like it. Or you could just say double the outputs. Down 2, I like it. So what I did was I picked a better scale. Because I realized if I move my square root over 4, everything's going to be happening off the edge. So I think I made my scale by 2s from the beginning. And this can be 1s, Jeff. There you go, buddy. So the base function 0, 0, 1, 1, 4, 2, right? So I'm just going to give myself those points. There's my base function. And then I just take each point and do these 3 things to it. Right? So like this point's going to go right 4. I'm going to double the output. Well, that's 0. And then I'm going to go down 2. Did I? Let me see. Now I'm questioning past Jeff. No, I did. Yay, good job, Pastor. For a moment there, I thought I went too far over. So here's the base function. Now, the one thing you might have a question about is the scale I picked. When I ask you to graph something, you can pick whatever scale you want. Just be consistent and pick a scale that makes sense. If I made it 1, 2, 3, 4, 5, do you see how if I move this over 4, everything's happening off the edge after that? So let me just pull it back in by making my scale a little bigger. So I can kind of see over further, yeah? Is that all right? So then I'll take this point, what happens to this point?
Right, 4.
Yeah, 1, 2, 3, 4. I double the output,
2,
and I go down
2.
2. Is that what I did? Oh, I didn't even use that point, did I? I just used 2 points. And then this point, 2, 4, double the output, down 2. So then it should look like, wee. Oh shit, Jeff, you shouldn't look up there. You should look down there. Another reason you should use pencil, dear God. Is that better? Okay. List the transforms, graph the base function, move each point, regraph. How do I check myself? Check myself. If I plug an 8 into this, what should I get out? 2. 8 minus 4 is 4 squared root of 4 is 2 times 2 is 4 minus 2 is 2. Yay! So you can check your answer by picking a point that your new function goes through. Make sure it works. It's supposed to. That is supposed to be the graph of the function. So every point it goes through better work.
If you had the 2 inside the radical, that would double the x.
Oh, if that 2 was
Yeah,
in
I'm
here,
just trying to double
it
x.
would
No.
cut it in half. It would take the
Oh,
x
that's
and-
right.
Yeah.
Ah, this-
It does, when it's inside, it does the
Right.
opposite of what it's like. If the first thing I do is cut my x's in half, don't they all have to be twice as big? Or if the first thing I do is double my x's, can't they all be half as big?
Yeah.
So 2 inside would actually be a compression.
And if it was less than 1, like
Then it would be a
1/2,
stretch.
then it would be a stretch.
Stretched by a factor of 2.
Yeah.
Inside, just like you guys, why is it right 4? Doesn't it say minus 4? But y'all know by now that I have to overcome. Take $4 away from me, I better bring 4 than I used to. So if I put a 2 here, somebody's going to double my money. So I can go there with half the money I normally would need. Yeah? Don't expect that, kids. It's not going to happen. I always think if I win the lottery, I just have fun, like giving random people some. But it hasn't happened yet. I'm sorry, I can't do that. I don't play it. When are quiz corrections due? Tomorrow. Homework's due tomorrow. When are homework corrections due? Day of the final, 11. What if you don't have your quiz corrections done tomorrow? You give them to me Monday. Is that all right? Yeah, you just, it'll be late. You won't get as many points, but the sooner you turn it in, I'll give you more points. But if it's late, you start to go down in terms of how many points you can get. You guys kind of with me? But you can still turn in everything late if you really wanted to. It's all going to count a little less, but it'll count a lot more than 0. Yeah. By the way, I'm pretty sure I had this discussion with you, but if you're like really behind in homework and the test is tomorrow, you do not want to come tomorrow not having tried problems from sections at all, right? You don't want entire sections you didn't look at. So stop trying to do every problem I assign. Start doing every other one. Stop doing a section, do the next section. I mean, you need to practice all the different kind of problems you could see. And then you just give me whatever you can, and I'll tell you to finish it or whatever, and you will if you have time. The most important thing is get ready for tests, because they're the heaviest weighted things. So if you have no more questions, you don't have to sit there staring at me. You could head out. If you have more questions, ask away. If you just want to stay in case somebody asks a question, we'll just stare at each other for a while. And I have quiz 1 corrections in chapter 3 homework with no names. So in case you did those and didn't get them back from me, that might be sitting right here. Huh? Quiz 1.
Thank you.
See you. That's you?
Yeah.
All right, put your name on there. Oh, do I have that? Okay, I'll put them in. Thank you.
See you later. How many weeks did you spend on trade?